Okay, so we're gonna start now. So we'll be continuing our topic from last class, which was systems. So I'll just do a quick review of the topic, and then we can go over some of the homework problems. And then if we have time, we can go on to some different techniques like manipulation. So, okay, let's just go over the homework first. So I don't think everyone got the chance to complete it yet, so I won't be going over the whole thing. So if you didn't do the homework yet, then I'd advise you guys to try and do it as soon as possible. And it's completely fine if you can't do all the problems. Okay, so the first thing we'll do is 5.23a and b. So this is just the standard systems of equation. So we have 3x minus 4y equals to 26, and 5x plus 8y is equal to 3. So hopefully you guys remember our technique for elimination, and that is like when we try to sort of eliminate one of the variables by equating the coefficients of it. So for example, over here we can see that the coefficient of y is minus 4, and the coefficient of y in the second equation is 8. So basically, if we just multiply the first equation by 2 on both the left and right hand side, we'll get 6x minus 8y is equal to 26 times 2, which is 52. Oh, okay, thank you for reminding me. Okay, so we were just doing the first problem on the homework from last week. Just 3x minus 4y equals to 26, and 5x plus 8y is equal to 3. Okay, so as I was saying, we're just going to use standard elimination for this problem. So you notice that the coefficient of y in the first equation is minus 4, and the coefficient of y in the second equation is 8. So if we multiply the first equation by 2 on both the left and right hand side, we can sort of get rid of this y variable entirely. So if you multiply by 2, you should get 6x minus 8y is equal to 52. And then if you add these two equations, you'll get 11x is equal to 55. So x is equal to 5. And then if you substitute x equals to 5 back into either of these equations, you'll get that 3 times 5 minus 4y is equal to 26. So 11 is equal to minus 4y. Y is equal to minus 11 over 4. So that would be the solution to this system. So does anyone have any questions on this problem? Okay. So let's just go on to 5.24. So 5.24 asks us to find the value of the constant a such that the system of equation 3x plus 2y equals to 8 and 6x equals to 2a minus 7 minus 4y has infinitely many solutions xy. So we have 3x plus 2y is equal to 8, as well as 6x equals to 2a minus 7 minus 4y. And we want this system of equations to have infinitely many solutions. So let's just move everything to the left-hand side in the second equation. So then we get 6x plus 4y equals to 2a minus 7. So as a reminder, let's just go over our criteria for when we have either infinite or no solutions. So if something has infinite solutions, then when we try to solve the systems, we just arrive at an equality, which would be, for example, 2 is equal to 2. But if it has no solutions, then we'd arrive at an inequality. For example, 0 is equal to 16. So what this means is that, let's just take this example over here. So it says 5x plus 2y is equal to 7, and 10x plus 4y equals to minus 3. So obviously we'll try to solve this system using some method. Let's just say we use elimination. So to use elimination, we'd multiply this first equation by 2. So you get 10x plus 4y is equal to 14. So now let's subtract the blue equation from the black equation. So if we do that, we get 0 is equal to minus 3 minus 14, which is minus 17. So now, obviously 0 is not equal to minus 17, so we can say that this system has no solutions. So, on the other hand, let's look at when a system would have infinite solutions. So we have this and this. So again, we'll try to solve this system with elimination, which means we'll just multiply the entire first equation by 2. So then we get 10x plus 4y is equal to 14. So now if we subtract the blue equation from the black equation, we get 0 is equal to 0. And this is true, so that means that there's infinite solutions. Okay, so does anyone have any questions on when a system has 0 solutions or infinite solutions? Okay, and also if you think you got it, then I'll give you guys like 2 minutes to try this problem, and then I'll go over the approach you can use to solve it. So essentially we just want to find the value of A that would make the system have infinite solutions. Okay, so I think that's right, but we'll just go over like this method we used, which is basically the same thing as what we did in the review. So we have this system of equations, 3x plus 2y is equal to 8, and 6x plus 4y is equal to 2a minus 7. So we see that this would probably be easiest to solve with elimination. So we multiply this entire first equation by 2, and we get 6x plus 4y is equal to 16. So then we subtract the red equation from the black equation, and we get 0 is equal to 2a minus 7 minus 16, or 2a minus 23. So if this system has infinite solutions, then we know that we have to arrive at the statement 0 is equal to 0. Or the only value of a that would make this true is 2a is equal to 23, or a is equal to 23 over 2, which, as you said, is 11.5. So basically, the thing here was to notice that the problem said the system has infinite solutions. So once we arrive at the statement 0 is equal to 2a minus 23, we know that this 2a minus 23 side also has to be 0. So then we just solve for a, and we get a is equal to 23 over 2, which is 11.5. So does anyone have any questions on what we did here? Okay, so if not, we'll move on. Okay, so let's do 5.37. And then we'll go back to what we were doing last class, I think, which was multivariable systems. So the problem wants us to find the value of x over y, given that x plus 1 over y is equal to 4, and y plus 1 over x is equal to 1/4. So I'll give you guys a couple minutes to try this problem, and then we'll go over it together. Okay, so as a hint, consider what happens when you multiply this whole equation by y and when you multiply this whole equation by x. Okay, so let's go over the problem now. So using my hint of multiplying the first equation by y, second equation by x, you should get that xy plus 1 is equal to 4y, and xy plus 1 is equal to, what did I do? 1/4 x. So notice that we have xy plus 1 here, and we have xy plus 1 here. So we know that xy plus 1 is equal to 4y, but xy plus 1 is also equal to 1/4 x. So this just means that 4y is equal to 1/4 x. So now divide both sides of the equation by y. So we have 4 equals to 1/4 times x over y. And so 16 equals to 4 times 4 is equal to x over y. So the answer is just 16. Okay, so does anyone have any questions on what we did here? Okay, if not, let's just move on to our slideshow. And also, I think most of you guys didn't do the homework from last class yet. So try to do as many problems as you can from here before next class. Okay, so now let's go back to our topic of multivariable systems. So we've only looked at system of equations for two variables, usually x and y. But we can have systems of equations for more than two variables. So for example, we might have a system for 3 equations, which would require 3 variables, or 4 equations, which would require 4 variables, and so on. So let's look at our first example here. And even though these may seem more complicated than just our 2 variable systems, the strategies from before still apply. So in these type of problems, you'd still apply substitution and elimination, but the difference is that you'd have to apply these steps multiple times. So let me do this problem as an example. minus 2x plus 5y plus 7z is equal to minus 66, and 3x minus 2y plus 3z is equal to 7. So this would be an example of a 3-variable systems of equations. So the problem here, they sort of guided you through the steps. So I'll give you guys a few minutes to do parts A, B, and C, and then I'll go over the solution. Okay, so let's go over this problem part by part now. So basically, part A just tells us to solve the first equation for x. So what it means is just look at this first equation and just rearrange it so that it isolates x. So this is pretty simple. So we just say x is equal to 25 minus 3y plus 4z. So now, part B tells us to use our answer to A to turn the second and third equations into a system of 2-variable linear equation. So we see that we have an x in both the second and third equation, and we just isolated our value of x. So what we can do is substitute this expression for x into the second and third equation. So you get minus 2 times 25 minus 3y plus 4z plus 5y plus 7z is equal to minus 66, and 3 times 25 minus 3y plus 4z minus 2y plus 3z is equal to 7. So now we can simplify these two expressions. So we get minus 50 plus 6y minus 8z plus 5y plus 7z is equal to minus 66. And then we get 75 minus 9y plus 12z minus 2y plus 3z is equal to 7. So then again, we can combine like terms in these two expressions to get 11y minus z is equal to minus 16, and minus 11y plus 15z is equal to 7 minus 75, which is 68. So does anyone have any questions on how we arrived up to this step? Okay, so now we just have a simple two variable systems, and we all know how to solve this, which we can do just by adding these two equations. So if we add the two equations here, we get 14c is equal to minus 16 minus 68. This is 14c equals to minus 76 minus 8, which is minus 84. So then from here you get z is equal to minus 6. So if z is equal to minus 6, you can substitute this value back into the first equation, and you'll get that y is equal to minus 2. And lastly, we have to solve for x, which we can do from this expression here. So since we know that x is 25 minus 3y plus 4z, then we know that x is equal to 25 plus 6 minus 24, which is just 7. So x is equal to 7, y is equal to minus 2, and z is equal to minus 6. So does anyone have any questions on this problem? Okay. So I'll give you guys a few minutes to solve this equation completely from scratch, and then I'll go over it. So you can use the same method from before of isolating some variable in terms of the other two variables, and then substituting that into the remaining two equations. Okay, so let's start going over this problem. So the first thing we'll do is try to find what the best way to go about this would be. So we could try substitution, but then we'd have to deal with fractions, and that wouldn't necessarily be that computationally feasible. So instead, we'll try to look for elimination. So notice that these last two equations have coefficients of z that are easy to deal with. So if we just multiply the entire second equation by 2, then we can get rid of the z coefficient. So let's do that. So write down 5x plus 2y minus 8c is equal to 29, as well as 7x plus 6y plus 4z is equal to 49. So multiply this entire second equation by 2 to get 14x plus 12y plus 8c is equal to 98. So now let's add these two equations. So you should get 19x plus 14y is equal to 127. So then we can try doing the same thing for the first equation and maybe the third equation. So we have 2x minus 3y plus 6c is equal to minus 12. And 7x plus 6y plus 4z is equal to 49. So if we multiply this first equation by 2, and okay, so the key thing here to notice is that we still want to get rid of the z no matter what. So even though it looks tempting to multiply this first equation by 2 so that we can eliminate the y, that would be kind of pointless since we don't need to eliminate y, we need to eliminate z. So what we do is we multiply this first equation by 2, the second equation by 3. So this gives us 4x minus 6y plus 12z is equal to minus 24, and 21x plus 18y plus 12z is equal to 147. So then we can subtract the first equation from the second equation to get 17x plus 24y is equal to 147 minus 24, which would just be 171. So then we have the system of equations in two variables. So we have 19x plus 14y is equal to 127, and then 17x plus 24y is equal to 171. And from here, I'm sure all of you guys know how to solve this. You can either use substitution, which would mean, for example, just isolating x in this first equation and then substituting that into the second equation, or you can try elimination. So as far as I know, this there isn't really a nice way to do this. Like, there'd still be a good amount of calculation, but it's important that you understand the method of solving these three variable systems. So does anyone have any questions on the strategy we followed here? No? Okay. So we'll just go over a quick word problem before we end class today. So let's look at 5.34. So it says square root of x plus 2 times square root of y is equal to 3, and 2 times square root of x the square root of y is equal to 0. So in this problem, it would probably be easiest to use substitution. So in the second equation, we can rearrange to say square root of y is equal to the negative 2 times square root of x. So then substitute this back into our first equation. And that would give us square root of x plus 2 times minus 2 square root of x is equal to 3. So then we have minus 3 square root of x is equal to 3. So square root of x is equal to minus 4. So then, if square root of x is equal to minus 1, then square root of y is equal to 2. But the thing is, like, this might be tempting, so if you square both sides of this, you'll get x is equal to 1 and y is equal to 4. But the thing is, you can't really do that here, because the square root of a number, it technically can't ever be negative. So it's not really possible for square root of x to be equal to negative 1. So to see this, if you plug in x is equal to 1 and y is equal to 4, you'll get 1 plus 2 times 2 is equal to 3. And obviously 5 is not equal to 3. So this is obviously not a solution to the given equation. So basically what can be confusing here is that even though the equation square root of x is equal to minus 1, when squared on both sides, gives the solution x equals to 1, we always take the principal root of a number. And the principal root of a number just means the positive square root. So once you notice that it must be true that square root of x is equal to negative 1, then we can automatically say that there's no solutions to this equation. So does anyone have any questions on why this has no solutions? No. Okay, so if not, I think that's all we have time for today. So I won't be assigning new homework since I think most of you guys didn't really get the chance to do the other one yet. And yeah, if you have any questions, you can put a comment on the post